Good day everyone, and welcome to your favorite mathematics lesson from Young Brains Academy. My name is JJ Thompson Oladele. Today we shall still continue our lesson on variation, and we are considering joint variation. What is joint variation? Joint variation involves three or more variables. It could be a combination of direct and indirect variations, or direct and inverse variations, or inverse and inverse variations. Example 1. Suppose z varies directly as x and directly as the square of y. Write the relationship between them. Solution. In this type of joint variation, it involves direct and indirect variations. So it can be written as z is directly proportional to x and to the square of y. While we introduced constant k, it becomes z equals kx y squared, where k is the constant of proportionality. Example 2. Suppose p varies directly as the square of x and inversely as y. Write the relationship between them. This kind of joint variation involves direct and inverse combinations. Solution. P is directly proportional to x squared and inversely proportional to y. We move further to introduce constant k. It then becomes p equals to kx squared divided by y, where k is a constant of proportionality. So the relationship between them is p equals kx squared divided by y. Example 3. Suppose the quantity p varies directly as q and inversely as the square of r. When p equals to 35, q equals to 7, and r equals to 4. Find 1. The relationship between p, q, and r. 2. Find p when q equals to 5 and r equals to 8. Solution. Roman figure 1. Since p varies directly as q and inversely as the square of r, we can then have our p is directly proportional to q and inversely proportional to r squared. Introducing our constant, we then have p equals kq divided by r squared. We need to substitute for the value of p, q, and r in order to find our k. So p equals 35, q equals 7, and r equals 4. We then rewrite as 35 equals 7k divided by 4 squared. Cross multiplying, we get 7k equals to 35 times 16. So 7k gives 560. To get our k, we divide both sides by 7, which is the coefficient of k. So we have k equals to 560 divided by 7. K equals to 80. The relationship between p, q, and r can then be written as p equals 80q divided by r squared. Having substituted k equals to 80 into the relation. Roman figure 2. Find Q when P equals to 5 and R equals to 8. Recall that the relationship between them is given as P equals 80Q divided by R squared. Now we have our P equals to 5 and R equals to 8. To find Q, we substitute for the value of P and R. So we have 5 equals to 80Q divided by 8 squared, which gives us 80Q equals to 5 times 64. Then we have 80Q equals to 320. Dividing both sides by 80, we have Q equals to 320 divided by 80. And our Q therefore gives us Q equals to 4. Before the end of the lesson today, let us see some practice questions. Suppose Z varies directly as X and directly as Y. When Z equals to 6, X equals to 3, and Y equals to 4. Find 1. The law connecting Z, X, and Y. 2. Find Z when X equals to 7 and Y equals to 4. Thanks for watching. Please follow, like, comment, and share this video. See you next time.